So here the first possibility is that if the R and O don't match, in that case, we have to find the minimum one here, and then we can either remove this R character and then take the edit distance between HO and RO. I mean, removing this, deleting this R character. So we can define this problem as just like we have done ED of HOR RO would be one, at least one, because we have got R and O which are not matching. And now we are trying to divide this problem into one of the possibilities by removing this R character and just choosing HO and RO. So it would be 1 plus ED of, we have removed R from HOR, so it should be HO and RO. Now this was one possibility after deleting R. What we can, if we can delete O also here from the target string, so we are left with HOR and R, right? Because it's also like possible that I remove something from word one, or I replace something or insert something, and finally arrive at this problem. So first we tried in this condition. First condition was that we tried removing R from the word one, and in the second possibility is that we remove O, and then we compare between HOR and R. So again, this problem, this is another possibility. That one we have already got, and we have removed O from here, from RO. So it would be RO and HOR, because we are still taking this. Deleting this first, and then dividing and breaking it down into the subproblem. Now there's another third possibility that we can only choose between HO and R. I mean, we delete both R and O and then find the remaining edit distance between these two characters. So I'll just copy this again. So it would be, we remove R and O from both. So it would be HO and R. Yeah, this. Now we have seen that actually in this problem, we want to find the minimum edit distance. And now if the character don't match, in that case, there are three possibilities. And there's a possibility that, I mean, either of these three like edits will give me the minimum distance. So now we can derive this, right? That we need the minimum of all these operations, the minimum number, which is from this output. So we can further like generalize this problem that it should be minimum of this, all this ED of whatever we have derived here. It can be minimum of HO and RO, HOR and R, and HO and R. So then we proceed with, so we have count for this, and then we keep on proceeding by breaking this problem by using this algorithm. If the character match, then in that case it's very simple. We just move to the previous. We just remove that character from our problem and make it into a subproblem by just taking the previous characters from the string. And if the character don't matches, we find 1 plus minimum of after editing or deleting or removing one character from either word 1 or word 2. So this is the algorithm that we were talking about, and now I will just solve this using the dynamic programming 2D grid in the next video.